Assalamualaikum, students and friends. Welcome back to Sir K Loves Physics and Chemistry video tutorial for high school students. Today's episode is a revised edition of a past upload on cross product of two vectors. Join me till the end of this video as we discuss vector multiplication in more details. So just sit back, relax, watch and learn. The question is, given two vectors, vector A equals 4.00 plus 7.00 and vector B equals 5.00 minus 2.00. Question letter A, find the magnitude of each vector. Question letter B, find the vector product A cross B, both in magnitude and in direction. The two given vectors are expressed in their unit vectors I and j, such as vector A equals 4.00i plus 7.00j, and vector B equals 5.00i minus 2.00j. We are required to find, letter A, the magnitudes of each vector A and B. And letter B, we also asked we are also asked to find the vector product of vectors A and B, all right, which we label here as vector C. And we will be computing the magnitude of vector C using the formula C equals AB sine of the angle phi, which means we will multiply the magnitude of vectors A and the magnitude of vector B, and then multiply this by the sine of the angle phi. We define the angle P as the angle between the two vectors when they are drawn tail to tail. Moving on to our computations, we have the magnitude of vector A equal to the square root of the sum of the squares of AX and AY, right? Which is, when substituted, all right, the magnitude of vector A equals the square root of 4.00, that will be squared, plus 7.00, that will also be squared. And we obtain the magnitude of vector A equal to 8.06 units. Similarly, the magnitude of vector B, all right, is also equal to the square root of the square of the x component bx and by. All right, substituting, we get the magnitude of vector B equals square root of 5.00, that will be squared, plus negative 2.00, that will also be squared. And doing our math, we will get the magnitude of vector B equal to 5.39 units. Next in our computations is to find the angle phi, using the formula. Angle P equals the inverse of the cosine of the quantity A dot B divided by the product of the magnitudes of vectors A and B. But we first compute the scalar product A dot B, right? That is equal to the x component of vector A times the x component of vector B plus the y component of vector A multiplied to the y component of vector B. So substituting the values, we get A dot B equals 4.00 times 5.00 plus 7.00 times negative 2.00, and we will get the scalar product, or A dot B, equals 6.00 units. Earlier, um, we have already obtained the magnitudes or absolute values of vectors A and B. All right, the magnitude of vector A is 8.06, while that of vector B is 5.39. So we can also find the product of their magnitudes, all right, or the absolute value of A times the absolute value of vector B. That is 8.06 multiplied by 5.39. So we will get 43.4 units. That means we can now proceed in computing the angle phi. All right. So we just substitute the inverse cosine of the quantity A dot B, which is 6.00, all right, divided by the product of the magnitudes of vectors A and B, which is 43.4. So using our scientific calculator, we will uh, get the angle P equal to 82.0 degrees in three significant figures. As shown in this figure, the two vectors, vector A and vector B, have already been drawn in the xy coordinates, and their tails are already connected, right, with the angle phi also indicated. So we can now determine first the magnitude of the vector product of A cross B, which is labeled here as vector C, and that is just equal to AB sine the angle P, which means that we will be multiplying the magnitude of vector A by the magnitude of vector B, which we already have computed earlier, and then their scalar product will be multiplied by the sine value of the angle P. That is 8.06, which is the magnitude or absolute value of vector A, multiplied by 5.39, the magnitude or absolute value of vector B. All right, so the scalar product will be multiplied by the sine value of 82.0 degrees. So with the help of your calculator, we will find that the magnitude of vector C equals 43.0 units. All right, and in determining the direction of this vector C, we again make use of the right hand slop rule shown in this drawing, right? So extend your forefingers and your thumb in such a way that they form a 90-degree angle, right? So the thumb represents the y component of vector A, all right? While the other four fingers represents the x component of vector B, all right? So, the thumb, when we follow the direction of vectors A and B in our diagram here, all right, the thumb representing a sub y must be directed in the positive y-axis, all right, while the other four fingers of your right hand should be pointing towards the positive x-axis because that is the direction of the x component of vector B. So if you have done that, take note where uh, the palm of your right hand is facing. All right. When you do the slapping, the direction of your slapping or the direction of your right palm will be facing, all right, away from you or into the page, and that represents the direction negative z. All right. So we therefore emphasize that the direction of the vector product A cross B labeled as vector C is into the negative z axis. Another method of determining the vector product of vectors A and B is using the component method. We will do this component method, all right, to verify if our answer earlier is indeed correct. So, we have once again the given vectors in their I and j unit vectors. That is, vector A is equal to 4.00i plus 7.00j, and vector B equals 5.00i minus 2.00j. All right, so from these two equations, all right, we emphasize that the x component of vector A is 4.00 units, while its y component is equal to 7.00 units. Obviously, it has no z component. Similarly, for vector B, its x component is 5.00 and its y component is negative 2.00 unit. It has no z component either. Now, to determine the x component of vector C, all right, that is Cx. The formula is just to multiply ay times bz minus az times by. That is, Cx equals 7.00 times 0, all right, minus 0 times negative 2.00, and we will get 0 as the x component of vector C. Similarly, the y component of vector C can be determined using this formula. All right? So Cy equals AC times Bx minus Ax times Bz. Substituting, we get Cy equals 0 times 5.00 minus 4.00 times 0. So that is equal to 0. So the y component of vector C is just equal to 0. And finally, for the z component of vector C, the formula is ax times by minus ay times bx. Substituting, we get 4.00 units times negative 2.00 units minus 7.00 unit times 5.00 unit. Doing our math, we will get negative 43.0 units as the z component of vector c. Alright? So that means the vector product of vectors a and b, which is labeled as vector c, has a magnitude of 43.0 units, alright? And its direction, as represented by this unit vector k, is in fact directed into the negative z axis. And that jives with our first answer earlier. So that concludes our tutorial for this topic. Till the next episode, mabuhay. Masya Allah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.